It is too late. A major transmission project needed today may have started its approval process a decade ago. We're talking 10 to 13 years from proposal to operation. And the strange part is, the technology was never the problem. We already know how to build the towers. We know how to move electricity hundreds of miles. The delay happens before a single crane arrives. Land has to be secured. Routes have to be approved. Environmental reviews have to clear. Regulators have to sign off. And one unresolved parcel of land can hold up an entire project. So while a factory is ready to open, a new power plant finishes construction, or a city needs more capacity, the wire connecting them might still be waiting for permission to exist. When it arrives too late, the cost doesn't stay with the utility. It reaches businesses, workers, and eventually your electricity bill. This is the investigation. In 2022, a major manufacturing developer cleared 600 acres outside a Midwestern industrial park. The capital was secured. The foundations were poured. Heavy production machinery was placed on order with 18-month lead times. From an operational standpoint, the facility was ahead of schedule. Then came the interconnection request. The plant needed 300 megawatts. The utility's answer arrived inside a 200-page engineering report. The local 115 kilovolt circuit was already operating at 98% of its thermal limit during summer peak. Connecting the plant would require a new 40-mile, 345 kilovolt transmission line across private farmland and 2 county boundaries. The factory took 24 months to construct. The transmission solution would take years. 7 years, in this case, just to clear preliminary route selection. So now the strange part begins. A $50 million facility is sitting there fully built. The transformers remain de-energized. The factory finished its job. The grid has not. And this is where the investigation gets interesting, because a factory has a physical footprint. A transmission project has a route, and that route has to exist somewhere. On a desk in a utility planning office, a transmission line looks like a simple solution. An engineer draws a 40-mile line connecting a substation to a power source. 30 seconds. Problem solved. Except the line doesn't exist on the desk. It has to cross the real world. Private farms, residential property, county roads, rivers, existing utility corridors. Every boundary it crosses introduces another property owner, another set of rights, and another decision. And transmission easements aren't ordinary pieces of land. The ground remains there. The restriction is above it. Landowners may face limits on structures, tree growth, access, and future development inside the corridor. So when the utility presents the route on a map, it isn't simply showing where the electricity will travel. It is showing people where their property rights will change. The utility sees a transmission corridor. The landowner sees a permanent restriction on property they own. And suddenly, the 40-mile line drawn in 30 seconds has a problem. Everyone along the route has to agree on where it goes. The line was easy to draw. Getting the real world to accept it is the difficult part. Once the line leaves the planning desk, it enters a maze of independent review systems. The utility doesn't deal with one central authority. It submits the project to local zoning boards, county officials, state utility commissions, environmental regulators, and, where federal land or waterways are involved, federal agencies. Each one has its own legal mandate. County officials look at land use and local impacts. State regulators examine grid necessity, costs, and rate impacts. Environmental regulators examine wetlands, erosion, and wildlife corridors. None of these reviews are inherently unreasonable. The friction comes from what happens when they interact. One agency spends 18 months reviewing the route and requires a modification. The utility moves the line half a mile. That change pushes the corridor into another municipality. Now another review begins. The new route affects a different group of landowners. The public comment process opens again. A decision made to solve one problem creates another process somewhere else, and the clock keeps moving. The transmission line has one destination. The paperwork has dozens. The project isn't necessarily stuck because someone said no. It's stuck because every part of the system gets a chance to say, change this first. One review at a time. Even if every regulatory agency approves the route, the project still faces its hardest physical boundary, private property. A 40-mile transmission line may require easement agreements with dozens, sometimes hundreds, of separate landowners. Most landowners negotiate in good faith. They agree on compensation, sign the paperwork, and the line moves forward. Then the project reaches the holdouts. Out of 200 landowners along the route, 3 refuse to agree. One owns family land held for generations. Another is concerned about agricultural equipment and access. A third simply doesn't want high-voltage towers visible from the porch. Now the utility has 2 options: reroute the line, or use eminent domain. Rerouting around 3 properties adds miles of transmission line, changes the corridor, and potentially triggers new environmental and regulatory reviews. Eminent domain allows the utility to acquire the easement through legal proceedings. But now the project has entered court. Eminent domain proceedings can add years to the project, and the line cannot be built through that parcel until the dispute is resolved. A multi-hundred-million-dollar transmission corridor is suddenly waiting on 3 pieces of private property. The engineering still works. The electricity is still needed. The line simply cannot pass through land the utility does not control. The transmission project was designed as one line. The real world divided it into hundreds of separate decisions. After years of lawyers, regulators, and landowners arguing over where the line can go, you would think the hard part is over. It isn't. Now they have to build the thing. Building a high-voltage line isn't just about stringing wire across towers. It's a heavy civil engineering operation spread across miles of changing terrain. First come the access roads. Heavy equipment can't cross raw farmland or soft wetlands without damaging the ground. Crews bring in thousands of timber mats and tons of crushed stone just to create temporary haul routes. Then come the foundations. Steel lattice towers and tubular monopoles require massive concrete footings. Drilling rigs sink shafts tens of feet into the ground before tons of reinforced concrete are poured for a single structure. Then the towers go up. Cranes raise prefabricated steel sections into position piece by piece. Finally comes the wire pulling. Specialized tensioners pull conductor cables through the air under controlled tension, keeping the wire off the ground and protecting the aluminum strands from damage. Every mile requires coordination between earth movers, drill crews, crane operators, and line workers, and the sequence matters. A delayed foundation doesn't delay one tower. It can hold up the stringing operation behind it. After years of permits, negotiations, and legal disputes, the project finally reaches the part everyone thinks is the easy part. Now it has to be built. After 10 years of planning, lawsuits, permits, and construction, the line finally looks finished. The towers are standing, the wires are up. So naturally, someone should probably turn it on. Not yet. A transmission line isn't a standalone wire. It has to connect safely into 2 substations, where the electricity is transformed, controlled, and protected. Before anyone closes the breaker, engineers have to prove the entire system knows what to do when something goes wrong. Lightning, a short circuit, a failed transformer, a fault somewhere down the line. Every protection system has to respond in milliseconds, because at this voltage, we'll see what happens, is not an acceptable commissioning strategy. So commission engineers test the relays, breakers, control systems, and communications under simulated faults. Only when the protection systems pass can the breakers finally close. And after years of planning, legal disputes, land negotiations, and construction, the entire project comes down to one quiet moment. The switch closes, the line energizes, and the piece of infrastructure that took a decade to build finally starts doing the one thing it was built to do: move power. When the switch closes, nothing looks different. The towers don't move. The wires don't glow. Nobody standing underneath knows the difference between a live transmission line and one that hasn't been energized. And after 10 years of planning, lawsuits, permits, negotiations, and construction, that's almost the funny part. The entire project disappears into the background. Inside the control room, the change is much less dramatic. A status changes from out of service to in service. The line begins carrying power. It takes pressure off other transmission paths. It gives the grid more room. It allows new demand to connect without pushing the existing system as hard. And then everyone goes back to work. There is no dramatic finish line. No one driving past the towers knows what it took to put them there. A few hundred towers now sit across miles of land, carrying electricity through a corridor most people barely notice. 10 years of work produces something designed to become invisible. Because when transmission infrastructure works properly, nobody thinks about it. They only notice when it isn't there. The transmission problem isn't simply a shortage of wires. It's a mismatch between the speed of modern economic decisions and the speed required to approve and build physical infrastructure. The system is designed to prevent bad projects, but the same process also makes necessary projects slow. We don't have a problem because we forgot how to build transmission lines. We have a problem because building one requires an entire system to agree on where it should exist. And by the time everyone agrees, the economy that needed the line might already have moved on. The question isn't whether we know how to build the wire. It's whether we can build it before we need it.